Let's continue our discussion of Chapter 2. We finished talking about the effect of topography in mountains, and the fact that as you go up in elevation, things cool off. Um, so, water and the relationship between land and water plays a role as well. Um, because water um, has the ability to either absorb a lot of heat or release heat, it tends to have a moderating effect on climate. That is, you could say also the temperature of water does not change as dramatically as the temperature of land. So towards in the middle of continents, large continents, you have what you call a continental climate. And here, this is showing the temperature range of these areas from the highest temperatures to the lowest temperatures. And this is in Celsius, I believe, so that you can see in the middle of Asia, you get wide range of temperature between summer and winter, and the same in North America, portions of North America. Um, Whereas out over the ocean, where there's lots of water, of course, you don't get nearly the range in temperatures. And so in coastal areas along large bodies of waters like ocean, you tend to see less of a range of temperatures as well. Um, so essentially, again, large bodies of water moderate the climate and reduce the variation in temperature that you might see otherwise. Um, so the change that we see with elevation is essentially what's called the lapse rate. Um, and that decrease in temperature with elevation. And what happens is, so as you go up in elevation, up higher in the atmosphere, there's less air pressure because the pressure is due to the air above you. And so as you go up, there's less air above you. So that means there's less pressure. There's fewer air molecules pushing down on you. Another way to think of that is that in a given unit of area of the atmosphere, at a lower elevation per unit area, you have more molecules than at a higher elevation. At a higher elevation, there's fewer molecules per unit area. The atmosphere is less dense. And so essentially, as you go up the mountain, the pressure is decreasing. There's fewer air molecules per unit area, which at really high elevations, why it can be difficult to breathe because there's literally less oxygen per unit breath that you take. Um, so at those higher elevations, there's less heat because the heat essentially is held by the air molecules. And so with fewer molecules, there's fewer of them to hold on to the heat. So thus the temperature drops. You can see the typical lapse rate per 1,000 feet in elevation. It'll drop about 3.6 degrees Fahrenheit. So precipitation varies around the globe from some areas that are quite wet here, some of these tropical areas, southern Asia, um, the northwest coast of North America. You can see the Gulf Coast can be quite wet. Um, and at 30 degrees latitude, north and south, again, we tend to find some relatively or sometimes very dry areas. Um, and so we said how that was generally due to these high pressure systems that develop at about 30 degrees north latitude. But again, that's not everywhere. I mean, it essentially applies to the desert southwest, but you can see the Gulf Coast is at about the same latitude. But sometimes proximity to water and prevailing winds can have an effect. So, for example, out here, the winds come from this way, and they don't really get onto deep into the atmosphere, not deep, but far into the continent to bring moisture to this area. Whereas in the Gulf Coast, the prevailing winds are coming this way, so they bring moisture from the Gulf of Mexico um, into the central and southeastern parts of the country. And in fact, a lot of the precipitation we get comes off of the Gulf of Mexico as these winds coming off the Gulf of Mexico meet up with winds coming from the west, which can bring um, very humid air over us and result in precipitation. Um, okay. The same effect happens in parts of India and Burma and Bangladesh, is that you have this air that comes off the Indian Ocean, and they have what they call the monsoon season, a time of the year where it rains a great deal because of the prevailing winds coming off the ocean. Um, so at a more local scale, we can talk about the climate, and we've talked about this a little bit already. Again, the effect that proximity to water has. And so here we are in the far east of Russia at fairly high latitudes. And we have a place that's right on the coast and one that's more interior. And so you can see the range of temperatures at this town, which I'm not going to try to pronounce really, is much less than this one that's further into the continent. You can see it has a much wider range of temperatures from a low of -40 up to almost 20 degrees Celsius, whereas the coastal place only varies from about -11, 12 degrees up to about 10. Again, all that water out here has a moderating effect on the climate, keeps it from being overly hot or overly cold. I've already talked about elevation, and so, but here's a good example. Ecuador is right on the equator. Chimborazo is um, almost right on the equator, and it's about a 20,000 foot mountain. So even though you're at the equator, when you're up there, you have a very mild, even cool climate, and cold, obviously, on the top of the mountain, comparable to what you might find in Colorado, which is much further north from the equator. Um, so mountain ranges and high elevation can mimic the kind of change in climate that we see as we go to more northern latitudes. So you see at the highest elevations in South America at the equator the same kind of habitats and climates that you would see as you move further north into North America and Canada. Um, so in a place like Ecuador, it's quite an interesting country because you can start at the coast, which is very low and it's very hot and humid, warm year-round and tropical. And as you move up into higher elevation, the Andes, you essentially move into the types of habitats that, again, you would find much further north. All right, here's a regional effect we see that affects precipitation, what's called the rain shadow. And so a mountain range, what it can do is if, and this is what we're looking at here is the Pacific Northwest, say Seattle or Portland. So you have prevailing winds that come off the ocean. They're bringing a lot of moisture with them. And what happens when you hit the mountain range is that air is forced up by the mountains. It cools down, the moisture in the air condenses, you get cloud formation and precipitation. So on the what you would call the windward side of the mountain range, you get a lot of precipitation. Um, a lot of moisture is lost from the air. And so as the air goes over the mountain and comes back down, it is now drier air and it's also warming up. Warm air tends to hold on to the moisture more, so you have a much drier habitat in what's called the rain shadow, or what's called the leeward side of the mountain. This is called the windward side. Um, so this is seen in Washington State on the windward side of the mountains out there. It's quite wet. That's where Seattle is. But in the eastern part of the state, it's much drier. So on a daily cycle in mountains as well, you see interesting phenomenon with temperature. And so, particularly on a sunny day, the higher elevations are being exposed to the sunlight first, and they start to warm up, creating rising air in a low pressure system. And that brings cooler air from the valleys up into the higher elevations of the mountains. But then at night, the sun goes down and those higher elevations rapidly cool down. Um, and so then cool air comes down from the higher elevations into the valleys. Um, and this is something that people who hike and camp in mountainous areas, particularly where there's bigger mountains, say out west, because the effect is stronger, they know that in the evening and night, cool air will be coming down out of the mountains. And if it's going to be a quite cool night, you might avoid camping in the valleys because you'll have that cooler air there. Sort of tends to sort of accumulate in the valleys. We see the same kind of effect at the shore, um, where during the day, again, the land heats up, creating lower pressure and rising air. This pulls air off of the ocean. That's cooler air. You get nice cooler breezes coming off the ocean. But then at night, the land cools down. And always keep in mind that land will cool off faster than water. Again, water tends to hold on to heat and its temperature change will change more slowly than land. So at night, the land cools down relatively quickly, whereas the water doesn't cool down as much. So now the water is warmer than the land. You get lower pressure out here, rising air, and it pulls air off of the land towards the ocean. This effect can be quite dramatic in some areas, and in particular in Southern California, they have certain times of the year where you have what's called the Santa Ana winds that come out of the mountains towards the ocean, and they can sometimes be quite strong breezes coming out of the mountains. Um, Cordilleras are walls or ranges of mountain, and they can influence um, weather patterns, climate patterns to a certain extent. So, in regards to the polar vortex, so you have this jet stream that we talked about, and essentially when it develops and the air starts moving from the Arctic down, it stays to the east of the Rocky Mountains because of they essentially form a wall, you might say, that sort of drives this air this direction as opposed to coming this way again because it's sort of blocked by the mountains. So these cordilleras or walls of mountain can influence wind patterns um, on a regional or even continental scale. Albedo, this is the degree to which a surface um, reflects light. And so where you have, again, here's Chimborazo, our picture from Ecuador. So you have pretty dark surfaces down here, and so this grassy area, this will tend to absorb lots of light. It has, we would say, a low albedo, whereas the snow up on the peak here has a high albedo. It's very reflective, and so the sunlight will tend to bounce off there and help maintain the cooler temperatures there, whereas down in the valley it'll be a bit warmer because that darker surface will be absorbing sunlight. Um, so the well, let's see. I guess I'll stop there because I'm just about out of time, and we'll pick up this in the next video.